YouTube? Welcome back to my garage. You guys will never believe what followed me home. I know, eat your hearts out. That's right, you're looking at bottom of the line import drill press. I think I had buyer's remorse before I actually even bought this thing. I'd really be hard pressed to tell you why I actually brought this home. I think deep down is just morbid curiosity. I was curious to see just how bad one of these things could be. You know, I've had this kind of stuff in the past before the hobby got serious. I think maybe I've just forgotten what these things are like. So this is a Valex brand. I'm in Europe, and this is essentially, I think, our equivalent of Harbor Freight. That's awesome. It's a 5-speed, step pulley. Some really classy plastic pulleys. It's the TR13. This thing must weigh, I don't know, 20 pounds, something like that. I think I'm going to do an autopsy. Just see how they did it. I don't even expect to find any bearings in this thing, to be honest. Maybe one in the quill there on the spindle. Maybe we can turn it into something usable. By usable, I mean something to replace this when I just need to knock some holes, in something non-critical. I had to show you guys something. It actually has less run out than I expected. It's about 2 thou. It has more run out if I turn it faster. Quite a bit of slop in the spindle itself. It's a 2-inch extension. This is its max. That's got to be 50, 60 thou. Surprisingly, it doesn't have a lot of end play backlash in the rack and pinion. There's essentially 4 set screws to get the whole thing apart. On the little piece of plywood, I've got the head casting and the spindle assembly. Over here is just the rest of the parts. There's nothing too exciting here. Motor is a piece of junk. It's all stamped sheet metal. Even the bearing sheets are just a formed boss. The resistance is incredible. It must have a nice capacitor in there to get this thing started. The pulleys are plastic. I'm not that upset about plastic pulleys. Anyway, we'll check these out for run out. I may just true these up as best I can. I'm not going to sweat that for now. This is the head casting. It looks to be about maybe 3/16 nominal wall. It's actually more cast iron than I expected in this thing. And the big surprise for me is a grand total of 4 bearings in the spindle. So we've got 2 at the power side, and then we've got 2 in the quill. The quill is aluminum. These bearings don't feel too bad. I'm going to replace all 4. I can feel them sort of breathe out of parallel, let's say, as I rotate this. So either it was a hasty press fit. I doubt, a little shaft this small is bent. The quill, on the other hand, has a terrible feel to it. It's got this long, slender spindle on the inside. That could be crooked. It doesn't look too bad when I spin it around, but it might be fighting the bearings to stay straight. This looks like an aluminum casting with just a few contact points for the bearings. There's some nice strikes there to seat the bearing. You know, the shaft of the handle is no big surprise. I don't think these rack teeth are fully formed. I haven't measured the distance between the handle shaft and the quill. That might have been why I was seeing so little backlash. The fit of the quill in the casting is what you'd expect. You can feel that wobble there. I don't know if you guys can see that. Left to right isn't too bad. It's got this keyway. I think technically is meant to keep the quill from being able to spin, but I'm sure it does double duty as trying to take out some of that play. It's a pretty rough fit. But it actually makes 2 points of contact. I don't know if you can see down in there. Let me get a flashlight. It's supported on sort of both ends, about 2 inches apart. So what I think I'm going to do, almost on principle's sake, is maybe just remake a new quill. That's what the casting looks like there. So these numbers didn't turn out as bad as I had expected. The bore is surprisingly consistent. I mean, it looks like it was done in one operation all the way through to the bottom. It's not the smoothest surface, but it's consistent. The quill has some high spots, and I think it's due. So it's about 3 thou out of round, but it happens up at these corners, and I bet that's happened because of this bearing press fit in this, where it coincides with this slot. So these areas here are reading high, and it disappears by the time we get down to this end, and it's surprisingly round down here. The bearing on this side is on the outside of the housing. So there's a 4 thou diameter difference. That's 2 thou radial clearance. It doesn't seem like as much as it feels, but I'm going to take that down some. I'm going to start on the new quill. Piece of CRS in here. I'm just going to rough it down the size. I haven't gone much further. I want to test this out, and I'd like to cut the rack in before I put any more time into this thing. If I screw up the rack, I haven't invested too much time in just roughing this blank out. But if I would have counterbored and drilled and then screwed up the rack, that would have stunk. That's 171. I don't know if you can read that. I made mine a little bit tighter. That's 1574. So thou, diametrical tolerance. Let's try it in the casting. I'm going to set this to 2 inches, which would be the maximum travel of this quill. It's about 13-14 thousandths. Let's try our new blank next. It's 2 thou. It's a lot more than I was expecting. I mean, it's definitely a lot better, but I was expecting that to be a tighter fit. Alright, let's try to cut this rack. So I plan to cut this rack on the shaper. In order to do that, I'm going to need a tool. Now, I dug through my high-speed steel and I found this thing. I don't know what I meant to do with it. It almost looks like an attempt at a tooth profile. but it's already thinned out, so it'll save me some time. I'm set up on the grinder, and I've already done one side. I just have this on a 20-degree angle block for a 40-degree included angle. This isn't cutting any relief on the tool. There's the profile. I don't know how well you can see that. Now I'm just going to lay it flat and cut about 7 or 8 degrees front to back. This is very scientific. I guess my stainless steel protractor isn't stainless steel after all. A lot better than I used to be able to do freehand. Don't know if I've ever mentioned the shaper bunch in other videos. This is an Ohms 300. It's 12-inch stroke, 300 millimeter. Took me a little bit to get the vise trammed in and the workpiece square and the tool bit square. I'm using the down feed for the tooth depth on the rack, and I've got my ARO turned on. I've marked out and cut the first tooth just to make sure everything was working the way I had hoped. Seems to be doing a pretty good job now. I've already stepped over for the second tooth. Now it's just time to sit back and cut this rack. It's a little bit on the tight side. I gave it a quick wire brush off the shaper. I might go a little bit more aggressive and maybe just take off some of that sharp. So I think that'll work. I'm going to cut this to length, bore it, and counterbore for the bearings. I've got the new quill and the new bearings installed preliminarily. I also drilled 2 new holes for adjustment screws in the thicker sections where the support material is. I've only got one in there now because I've only got one of the right size. But so far, feels pretty good. So at full extension, a lot better than before. Okay, so totally unnecessary, but I figured since I got this thing broken down, I'm just going to throw a different color paint on here. I've got some of the gray left over from the surface grinder. I don't know how to explain it. The red machine in the shop seems like a slippery slope, and I'm not quite ready for any lifestyle changes. So that pretty much just leaves the motor. In terms of motors, the only thing I've got is this one here on the right. It's twice as fast. This is 2800 and this is 1400 RPM. This is 250 watt. This is a little bit more than twice that, 550. The only thing that's missing here is this hinged mounting plate. And through the magic of television, I've already got one made. Just screws on there and it'll hang in the same position on the housing. Also found the source of all that vibration. I don't know if you guys can see that. These have a steel bushing molded with the plastic on the inside. The plastic itself is quite round. It's just that position. I'm not sure if I'm going to be able to fix this. I'm going to try to ream that, but I think I may just have to make a new pulley. The same one on the spindle was surprisingly good, so I left that one on there. I wasn't able to true this pulley up. It was just, by the time I reamed it out, there was so little metal and I started to lose control of it. At one point I did open it up thinking I could put another bushing in there, and I just decided to make a new one. The only problem is I didn't have material large enough. So instead of a 5-speed, I've now got a 4-speed. That just came out of there. I went in and roughed in the diameters, cut pretty close to depth with a cutoff tool, and then decided to go in and try a forming tool. And I have some video of that process I'll inset here. I was expecting it to go worse in terms of chatter, but I tried to make it very sharp. I don't know if you can see that in there. There is some chatter. It's not the end of the world. It's actually worse when it hit the bottom, when I stopped at the diameter at the bottom. So I'm just going to put a couple of set screws in here. I'm debating whether to actually key this thing. The other one's not keyed. I may just set screw it. We'll see how it works. Well, here's hoping you can hear me. Just going by the sound alone, the drill press is doing a lot better. The pulley on the motor side is looking pretty darn good. I think we can get this a little bit quieter. I'm going to try to recut the spindle pulley. Not sure if you can see down in there. There was a little bit of out of roundness. Where I cut it is a little bit more opaque, and the original is glossier plastic. Let's get it on there and see how it works. Not sure, maybe a moderate improvement. Still not as quiet as I'd like it. I mean, it's a little better with the guard closed, but I'm still not overexcited about how that sounds. I think it's just going to have to come down to probably replacing that spindle pulley. Now, when I had it broken down, I tried the spindle bearings again, and all of that sounds very good and very quiet. I think it's the belt coming over this plastic pulley that's making that rattle, and maybe just some of the sheet metal in this guard. I think I can live with that for now. I'm sure I can keep tooling around with this thing until I've replaced so many parts I don't even have the original drill press anymore. Was it worth it? I don't know if that was really the point of what I was doing here. But yeah, I think it definitely sounds better. It won't walk away on me when I turn my back. The quill certainly feels a lot better, a lot smoother, not as crunchy. As just a quick go-to benchtop drill press, I think it'll do alright. I mean, it's certainly built to a price point. I'd still likely recommend looking for some, let's call it old iron. The whole they don't make them like they used to thing. I was planning on putting these keyless chucks on. These are ROM brand, made in Germany. I thought they were tapered, but it turns out they're a threaded connection. I'll just stick with the one that came with the drill press until I come across something a little bit more convenient. All that's left to do is find a spot in the garage for this thing.